Concept 2, solving a system of linear inequalities by graphing. Alright, so we know how to check to see if an ordered pair is a solution to a system of linear inequalities. And with our system of equations, we figured out a way, we used substitution, elimination, to mathematically solve and find that ordered pair that is the solution. With linear inequalities, we don't have just one ordered pair that's a solution. We have a lot of ordered pairs. We have an infinite number of ordered pairs. So what we are going to be doing when we are finding the solution to a system of linear inequalities is actually graphing. And we have to graph, right? That's the only way we can represent the answer or the solutions to that system. Okay? Otherwise, there's too many to list, and because they're lines, it's too hard to represent them any other way. Okay? So what we're going to be doing is we're going to be graphing these and looking for their overlap. All right, to find our solutions. Okay. So we have graphed our linear inequalities before. All right. The only thing we might have to do is fix, some of these equations so that they are in normal slope-intercept form. Okay. Other than that, it should be straightforward to graph them individually. So let's just start with this one because it is in slope-intercept form, and I'm going to underline it with green just so I can remember which one is which. Right. So I have y is less than x minus 1. So I'm going to go to my negative 1. And my slope is 1. So up 1, over 1. And I can put a point, put a point. Okay, so that's going to be my slope. And it'll come all the way up to there. And all the way down to there. And then I can just pop my line in. Let's make it green, arrows. Alright. Okay, so I've got my line. Oh, but I forgot. I got to check, right? If it's not or equal to, right? If it's just less than, it's not going to be a normal solid line because not all of the values on there will work. It's going to be a dotted line. Okay, good. So now I got my dotted line, and it's y is less than x minus 1. So the area I'm going to be shading is going to be below my line because it's less than. So it's going to be down in here. Right? I'll try and shade that quickly. Don't need to be too careful. Something like that. Okay, good. So done with that one. Move on to the other one, and that one I'm going to underline with red, but I'm going to have to mess with that one. So I've got 2y plus 6 is greater than or equal to 14. I'm going to isolate y, so I'm going to subtract 6x on both sides. 6x, and that'll get me 2y is greater than or equal to negative 6x plus 14, divide by 2, divide everything by 2, y is greater than or equal to negative 3x plus 7. Ooh, okay, so get my line, 1, 2, 3, 4, 5, 7, get my y-intercept, and now negative 3, so it's going to go back and up 3, or over 1 and down 3. Over 1, down 2, 3. Over 1, down 3. And it can often be, my last one will be somewhere in there. It can often be useful to do that and step it all the way along your graph so that you can get your lines straight. You don't have to, but you do want to make sure, because this is the only way we're going to represent our solutions, you do want to make sure your graph is as accurate as you can get it. Because if it's not accurate, you can get the wrong solutions. Okay, so this is greater than or equal to, so I'm going to be using a solid line, and plot that in there. Looks pretty good. And then this is y is greater than, so I'm going to be shading above the line. Shading, and wherever I'm overlapping is going to be a solution. And there we go. So this is a solution, but only to one of the equations, or one of the inequalities. This is a solution, but only to one of the equalities. Where they overlap is the only area where it's going to be a solution to both equalities, or both inequalities.